Welcome back. So it's a new week, new chapter, new day. Let's get to it. We are now looking at estimating population parameters from a single sample. So we'll get more to the table contents later, but basically, we are going to take an idea that was raised in the previous chapter and run with it. In particular, the section that most of my students like the least, 6.3, which was sample statistics, we found that if we had a lot of samples out there, we could take the mean of those samples, and that mean of sample data would be the best estimate of the population parameter. So the example we worked in that video series was I said NBC did their poll, and Fox News did their poll, and ABC did their poll, and CNN did their poll. And we took all the sample data, all the poll data, and we averaged all of them together, found a mean for all the samples, and that was our best estimator for the population. And we found also that you could do that reliably for some things, but not others. We found we could do it very effectively for proportions, for means, variance, and of course standard deviation, because we could do variance. But most of the time, there's not multiple polls out there. There's not multiple lists of data. We're lucky if there's one. More often than not, there's zero, and you've got to go get that sample yourself. So, how do we make estimates for the whole population from just one sample? That's going to be our goal in this video series, actually, for this whole chapter, I believe, is making a population estimate from one single sample. So, obviously, we're going to start with a sample. And this will be the sample that we're going to run with for this whole video series, for this whole section out of the book. Suppose for me that we've got a mayoral race coming up in Nashville, Tennessee, and we want to know who's going to win before the actual day happens. Now, we're not going to know, well, unless, we know everything, but we're just going to poll, say, 1,000 people. And we use good polling techniques, right? We do random sampling. We don't ask leading questions. We don't just leave it as an online poll somewhere. We do a good poll. And our good poll comes back that 550 of the 1,000 respondents would vote for Bobbert Bobbington, and the remaining 450 said they'd vote for the other guy. So based on this poll, can we conclude definitively that Bobbert will win? Can we say with 100% certainty that we know Bobbert will win? And the answer is, of course not. This is actually a running theme of the course. We can never be 100% sure of anything unless we have all the data. Right? When we have all the data, it stops being statistics. It starts being parameters. As long as we have an incomplete list of information, that's just statistics. So we can never, statistically speaking, be 100% certain of anything. But as we'll see in this section, we're going to be maybe 99% confident or 99.9% confident, right? As confident as we need to be, just never 100%. And so to set us up for that, here's how I'm going to play this. Here's how we're going to play this. Remember that sample distributions for proportions, or as we'll get to in the next series, means, or in the series after that, variances or standard deviations as well, they're all normally distributed. And they are distributed around the population mean, or the population proportion, or the population variance. So for proportions, right, we had 55% say they'd go for Bobbert and 45 said they'd go for someone else. Our sample proportion is somewhere on this normal curve for all the possible samples that could exist. Now, we only have one. So maybe if we're super lucky, we've got the one that's exactly at the mean. Or maybe we're close, or maybe we're not close at all. Maybe we asked the only 550 people in all of Nashville. But we've got a distribution.